Hello everyone, welcome to another video of science. Today's topic is sound. First of all, let me ask you a question. What is sound? Sound is something that we can hear, right? It is true, but it is more than that. According to Wikipedia, in physics, sound is a vibration that propagates as an acoustic wave through a transmission medium such as gas, liquid, or solid. So basically, sound is a vibration that can be heard through our ears. Sound is everywhere around us. For example, my vocal cords are producing what I am speaking now. Right now, when you are watching the video, it is done by the speakers from your device. Imagine if sound wasn't there. It would be terrible. Sound is amazing, and I hope you are eager to know more about it. I will be explaining the topics step by step based on the subtopics from the Class 9 NCERT Science textbook. So let's start. So, our first topic is production of sound. Sound is produced from vibrating objects. Vibration means a rapid to and fro motion of an object. That means whenever a sound is produced, the object from which it originated must have vibrated. Producing sound is very easy. Just strike a spoon against a steel plate and you will have produced sound. We produce sound. But how did it reach us? We'll get the answer in our next topic, which is propagation of sound. The matter or substance through which sound is transmitted is called a medium. It can be solid, liquid, or gas. Sound moves through a medium from a point of generation to the listener. The particles touching the vibrating object don't travel all the way to ear, but they push the adjacent particles, forming a wave which reaches the listener. Sound needs a medium to travel. Sound is a mechanical wave and needs a material medium like air, water, iron, etc. for its propagation. That means it cannot travel through vacuum. This is the reason there is no sound in space. Moving to our next topic, sound is a longitudinal wave. In a longitudinal wave, the particle displacement is parallel to the direction of wave propagation. In this photo, you can see the compressions and rarefactions of a sound wave. A sound wave is similar to this. This is the reason a sound wave is called longitudinal wave. Now comes the most important topic, characteristics of sound waves. The three main components of sound are frequency, amplitude, and speed. Frequency tells us how frequently an event occurs. We know that sound is an oscillating wave, so it will be repeating its motion. When the wave starts from its origin, it goes up, proceeds down, and then returns at the mean position. It completes one oscillation. The number of times a wave oscillates in 1 second is known as frequency. It is represented by V and its SI unit is Hertz. Amplitude is the maximum distance traveled by a wave from its origin. That means amplitude can be called a wave's loudness. That means its vertical height is perpendicular to the line of origin. Amplitude is represented by the letter A. Do you get something in mind when you hear amplitude? I guess it's amplifier. An amplifier amplifies the sound waves. That means it makes the wave louder. One more important characteristic is wavelength. It is basically the distance between two consecutive crests or two consecutive troughs. The next characteristic is speed. We know that speed is equal to distance upon time. So similarly, we have wavelength as distance and time as much as it is needed to calculate. Short notice, if by any chance you were thinking of closing the video, please watch till the end because I have tried an activity which is very interesting and required a lot of efforts. So do watch it. One of the most interesting phenomenon of sound is echo, which is caused due to the reflection of sound. We usually experience it in a cave because there are rock walls in every direction, which reflect the waves very easily. You can even experience it in a room which is empty. Echoing is nothing but sound wave getting reflected again and again. So finally, it's time for the activity. I have made a small setup which includes a speaker, a water line, and a phone to control the speaker. As I said, you can see a speaker and a water line going over the speaker which is connected to it. To make it work properly, we will have to match the FPS of the camera to the frequency of the sound being played on speaker. Right now my camera is shooting at 30 frames per second, so I will set the frequency to 30 Hz. The frequency is set. Now I just need to start the water and turn the speaker on. Everything is done. So let's start. On the count of 3, 2,